Hey everybody, my name is Chris and I'm a tutor here at Chegg.com, and I mostly do math and a little bit of computer science. And in this video, we're going to talk about solving absolute value inequalities. So here we want to solve the absolute value of 2x minus 5 plus 7 is less than or equal to 10. We want to solve this for x. Okay, so when we have absolute value inequalities, the very first thing that we want to do is isolate the absolute value part. So just have the absolute value part all by itself on one side of the inequality and everything else on the other side. So what we want to do in this case is first subtract the 7 from both sides. So we get the absolute value of 2x minus 5 is less than or equal to 3. Because if we subtract 7 from both sides, this 7 goes away, and then 10 minus 7 gives us the 3 over here. Okay, so that's what's happening there. Now, once we get to this part here where we have the absolute value all by itself on one side, what we do is split this up into two equations. So if the absolute value of 2x minus 5 is less than or equal to 3, what does that mean? Let's think about that for a second. So what is the absolute value of 3? It's 3, right? What's the absolute value of negative 3? It's also 3. What's the absolute value of 2? It's, fix that. It's 2, which is strictly less than 3, right? What's the absolute value of negative 2? Well, it's positive 2, which is still strictly less than 3. Okay, so my point is that here, if this thing in here, if 2x minus 5 is equal to 3, that's going to solve the equation. Or if 2x minus 5 is equal to negative 3, it'll solve the equation, right? Or if 2x minus 5 is equal to 2, or if 2x minus 5 is equal to negative 2, the equation will be solved. Or sorry, the inequality will be solved, rather. So the inequality will be satisfied in that case. So my point is that whatever is happening here inside of the absolute value symbols, whatever's inside of the absolute value symbols, we have to have the absolute value of that be less than or equal to 3. In other words, if we were to draw a number line, so let me go ahead and get rid of some of the stuff here, and then we'll draw this on a number line. So what does it mean for something to have absolute value less than or equal to 3? That means that its distance from the origin on the number line has to be less than or equal to 3. So we'll put 3 over here, and then negative 3 over here. All right, so we're talking about less than or equal to, so I'll use the square brackets. So in order for something to have absolute value less than or equal to 3, whatever the something is, it has to be within 3 units of the origin, okay? So since our something in this case is 2x minus 5, then what that means is that 2x minus 5 must be in this interval. In this interval here, from negative 3 to 3, okay? And that includes the endpoints, both negative 3 and 3, because we're talking about less than or equal to, right? It's not strict inequality, so we do have that going on here. Okay, so let's go ahead and, so how does that help us? What does that tell us to do? Well, if 2x minus 5 is in this interval, what does that mean? That means that negative 3 is less than or equal to 2x minus 5 is less than or equal to 3, right? So if 2x minus 5 is in this interval here, then that means negative 3 at the very left end of that interval has to be less than or equal to 2x minus 5, which has to be less than or equal to 3, the very right end of that interval. Okay? So this is actually two inequalities. Negative 3 is less than or equal to 2x minus 5, and the other inequality is 2x minus 5 is less than or equal to 3. So we have to solve both of these for x and see what we get, okay? So here, when we say the absolute value of 2x minus 5 is less than or equal to 3, we split that up into two inequalities like this, okay? So let's see now. Well, let's just look at these one at a time. So let me go to the next page, and I'll focus on these one at a time. So just to recap, we have the absolute value of 2x minus 5 is less than or equal to 3. So we had two inequalities from that. We had 2x minus 5 with no absolute value is greater than or equal to negative 3. And we also had 2x minus 5 is less than or equal to positive 3. So now we just have two regular plain old linear inequalities that we just want to solve for x. So here, add 5 to both sides. We get 2x is greater than or equal to 2. All right, now we divide both sides by 2, and we get x is greater than or equal to 1. And then over here, add 5 to both sides, and we get 2x is less than or equal to 8. Divide both sides by 2, and we get x is less than or equal to 4. So both of these have to be true together. So x is greater than or equal to 1, and x is less than or equal to 4. So what that means is that 1 is less than or equal to x is less than or equal to 4. And if we want to answer that in interval notation, that would be the closed interval from 1 to 4. So it's the closed interval because it includes the endpoints both 1 and 4. So that's why we have the square brackets around there if you're familiar with interval notation. Otherwise, you can probably just answer like this. 1 less than or equal to x less than or equal to 4. Okay, so this has been an example of solving an absolute value inequality, and I hope you found this video helpful, and thank you for watching.